Okay, so again, we have find all zeros, not just real zeros, all zeros. Zeros what? Zeros come from factors. So what they're not telling you is that you need to factor the polynomial. It doesn't say that, but if you're going to find all of these zeros, you're going to need to write some factors. Part of factoring is division. But let's go back to focusing on this. One of the definitions of zeros is x-intercepts. So if you don't want to try to factor something this gross, you can always start with a graph of the function. So if you come to your calculator, if you open your calculator, x to the fifth plus 3 plus x cubed plus 2x squared minus 12x plus 8. If you graph this, what do you notice? What types of intercepts do we have? How many do we have? We have one here. And what do we remember about bouncing off of an axis? What we have is a repeated zero. So from this graph alone, we can see there are 3 zeros in this window. If you want, zoom out. And you can tell that there aren't any other intercepts anywhere out to the left or the right along the x-axis. So those zeros that we had from the beginning are the only real zeros involved in this polynomial. So we have zeros of -2, 1, and 1. How many zeros is this function supposed to have? 5. So what are we trying to do? We're trying to factor this polynomial with what we have all the way down into its 5 factors. And like I said at the beginning, part of factoring is division. What kind of division do we have? What kind of division can we do with zeros? How about synthetic division? So let's start with 2. We're writing the coefficients for the terms in the function. We get a 0 for our first remainder. We immediately synthetically divide by one of those zeros that is a 1. Zero as a remainder, validating the fact that yes, this is a 0. Last but not least, we immediately synthetically divide by our last 0. Oops. And what did this start out as? This was the coefficient for x to the 4th. After the synthetic division, this is the coefficient for x cubed. I'm sorry, this was x to the 5th. This was x to the 4th. This is x cubed. This is the coefficient of x squared. So my final quotient from this division is x squared plus 4. Here I have the linear factor for -2, the linear factor for 1, and the linear factor for 1. Last but not least, because I have a degree of 5 for the polynomial, I need to have 5 factors. Right now I have 3 linear factors and 1 quadratic. This quadratic factor is the sum of squares, which breaks down into complex conjugates. Can I write it like that? Does that scare you people? Hopefully it doesn't. So my zeros, all 5 of them, positive 2i, negative 2i, negative 2, 1, and 1.